This is an LED throwie. If you're not aware of what it is, you take one of these big fat 3-volt coin cells, stick it across a light emitting diode, and the internal resistance of the very long shelf life lithium battery would work with the LED well enough that it would light it up. And you'd stick a magnet to it and then tape the whole thing together, and you could throw it onto any metal surface that was iron, like a bridge or whatever. This became an activity like graffiti and also basically dumping garbage around, throwing LEDs on things to light them up. It was also a handy way to make a flashlight. I owned one on my person. And there are ways of making it to where you could put on, let's say, a piece of tape that covered all of this except one little spot, and then have this insulated except one little spot, and then slide the LED in and out to make it a real functioning flashlight with a white LED, for instance. It would be bright enough, and you'd stick a magnet to it, not just to throw it onto a passing train and, be a nuisance to the public, but also so you could stick it to your bike and maybe use it as a bicycle light, or stick it onto something metal like something in your cars, like on the dashboard, and be able to use it as a directed light so you could use it for practical purposes. These were ridiculously efficient and simple and cheap methods. And you could do a red LED if you wanted to save your night vision. You could use that on the back of a bike. The possibilities were endless. But the problem with these is that they had a really long burn time. They would work for a long time, but they are kind of expensive per use. And they were considered something that were literally throwaway and also e-waste. Now we go forward a little bit. Adding a solar cell to it that's 3 volts and using a rechargeable version of the 3-volt cell, or if you wanted to, you could get a very tiny coin cell that was also 2 volt. It's a weird lead acid one, which is even worse for the environment, but people would also do those as well, and by putting a solar cell on it, you could make it to where it charged in a clever way with some passive components, where it'd shut off the LED and charge it all day, and then at night you'd have a light that would dimly light an area. Some people even use this to make yard lights and solar pathway lights, like some of you already have. These things are very commonly a throwaway item because they're almost zero maintenance for the 1 or 2 years they work. It represents a decent value, but usually they have a really big mechanism and housing, and they're generally, it's wasteful and it throws a lot of crap into the environment. Now, making a version of this that just solders on the back of one of these things, very popular, very commonly done, because a lot of these on the back of them have extra surface area with copper traces on them, and you could etch the surface or even scratch it with a knife to make the pattern, and you could solder on a circuit like that, and it would last a ridiculously long period of time. People would also use yard lights with their attendant battery packs at 3.6 volts, and these at 3 volts, and these LEDs, if they're white, wanting to work at 3.2 volts, you're starting to see kind of a pattern here, to run 3.3 volt mid-voltage systems that would use a solar cell that was like 5 volts. They're the larger ones usually, or specially made ones that are 3.3 or 3.6 volts to charge up these battery packs that would be made out of 3 triple or quadruple A batteries. And if you did that, you'd end up with something that wouldn't wear out in 2 years. It could last a very long time because the batteries would almost but not quite cover the back of this solar panel, and the rest of the circuit really just consisted of just wiring an LED and maybe a light sensor. Now, a special purpose part came out at one time to combine all of those components together and would also let you use just one of the batteries to run the LED all night, use the solar panel there that's still the same size, so it would definitely charge it up during the day. And all it was this chip, and this, it looks like a resistor, but that's actually an inductor, a coil. What would happen is you'd wire up the light emitting diode, or whatever it is you were trying to drive at 3 volts, between pin 4 and pin 3. Now, between pin 3 and pin 2, you'd put on your battery you were recharging, and then between pin 1 and pin 3, you'd wire on the solar cell. And this took care of all the electronics to make sure it wouldn't discharge the battery badly, and it would only run the light or drive the 3 volts. It's actually not 3 volts. I'll get to that in a minute. But it would drive the 3 volts or the LED only when solar cell wasn't feeding power in. Now, obviously, because this thing, I mean, this is tiny. It's smaller than a cornflake. And the coil here is pretty small too. This would be wired in sequence between the battery, the ground, or the battery, I keep forgetting which one, and the LED. Actually, I think it's between pin 2 and pin 4. Anyway, the way the circuit worked, if you're not aware of it, is you'd wire your light emitting diode to all this stuff, and what it does internally is it wires the battery and the LED in circuit back to ground. And then in the middle of it, you have this in sequence on top of the battery. And what would happen is it would temporarily short this to the other end of the battery, and then when it would release, it would cause a pulse of current of a specific milliamp rating and then run the current through the LED. This thing took care of most of the wiring and electronics. Now, that's a very short explanation. Please look up JouleThief, and it's Joul, and you'll find out how these work if you want to. But the main thing is this would let you use, again, one of the batteries with a solar cell like that. That would definitely charge it. And it would use this kind of circuit so that when the sun went down, it would run off of one battery, so you wouldn't have to worry about the batteries kind of like half discharging one of them and then charging up the others and them getting out of synchronization. And it would also work if you let it till the battery itself was destroyed, because it would absolutely suck every bit of power out of it by running the battery basically not to the LED, but mostly to dump electricity across the coil of wire. When you break a connection from a battery to a coil, it produces a pulse at whatever the current limit was that you set it at, or whatever current level it was at the moment. So if you ran current through it until this went up to, let's say, 10 milliamps, and then broke the connection, that inductive kick would produce a current burst that would go through the LED at the same current. So as long as you limited how much current was in, or limited the time you were running the electricity into the coil, it would produce a very reliable, very safe current. But it would produce a high voltage spike unless you put a capacitor across it or a battery or something like that. And that brings up the next stage. People figured out they could use this circuit with this little coil to charge a battery pack off of a lower voltage solar panel. Let me show you an example by going back again. Here's our supposed one single battery at 1.2 volts. But if we put them together here, we have a 3.6 volt pack. And if we use a 3 volt solar panel, it's not going to ever charge it. But if we use this to give pulses of, let's say, exactly 20 milliamps or whatever it wants, we could charge up our battery by running a lower voltage in. And the thing is, it would easily jump the 3 volt to 3.6 volt jump. Now I'm going to bring up where this went to eventually with another design. Now remember, this all started off with people literally taking a piece of duct tape, a magnet, a battery, and an LED and throwing them on things to make little Christmas tree light arrangements or whatever, or use them for a practical application. And that's actually the ancestor of basically your yard lights. Now this one here combines the parts. This has the battery on it, and this is a button cell, and it's written, I think, in Korean, but one of these is a rechargeable, so you could have put a solar panel with it, even a small solar cell that would be about the size of the coin cell. But this is the modern version of the throwaway because it'll run this button cell forever until it goes really dead. Like at 1/10 of a volt, it'll still grab current, dump it across the little tiny coil here, and this little chip will drive that LED, and it'll keep doing it. And yes, it can be combined with the solar panel because there's the pin for putting the solar cell on it to try to recharge this battery. Just put a rechargeable coin cell in it and it'll do the same job. In fact, it may do it better. And that one has to be the 5252F chip. There are variations of it, there are other ones, but they all work about the same. Some of them are more efficient than others. But the point is, this made it to where you could have your little blinky do this. And you could go ahead and put an LED on it that blinked or changed color or all sorts of stuff. Fun stuff. But what else could you do with this? Well, now you've got a high efficiency circuit for charging the LED. And also there's a variation of this thing I can't find that also charges the battery using the same charge pump. So it's always trying to do the best job, and it's tailor-made for the cell. This is a single circuit board, 2 or 3 chip, depending how you look at it, Wi-Fi hotspot and Wi-Fi basically access point trap. It runs at 3.3 volts. See, we're getting in similar ranges here. And it runs at 80 milliamps. Now, that's a quarter of a watt of power when it's doing something. When it's not doing something, it's running at like 1 milliwatt for standby. And if you tell it to power down and maybe turn on with a timer, it's using 9 microamps or something. And it can have this area over here. This is right here is the external flash device. It's a memory chip, hence the 8 pins. And it can be like 1 megabyte or 4 megabyte external flash. It's serial based. It's basically a USB drive kind of chip almost. And you can actually hook up other devices to it. And it's a Wi-Fi transceiver that's $4 and it's 1 by a 1/2 inch almost. And there are variations of this that are even smaller. And this thing runs at a voltage that's quinky-dinky, the similar voltage. Now, some people figured out to combine them by using a solar panel, sticking this on the back of it with a battery, and using that charge pump circuit that's based on making your pathway in your yard light up during summertime in summer evenings, and turn it into something where you have a little Wi-Fi hotspot that can, on this little memory brick, contain a web page or, be an advertisement for your company. Just, if you wanted to do this as some sort of guerrilla advertising. But what it can also be done with, because this is a general purpose input-output, a GPIO hookup here on pin 4, etc., is you could take 2 of these and use this to make a really tiny Wi-Fi repeater with passwords. Yeah, a Wi-Fi hotspot and repeater. And then we get to this. This is the antenna you can hack it with. This is one that still has a little funny connector on it, but you can strip that off. And what you do is you expose by removing the insulation over the coaxial shielded cable here, and you remove 31.25 millimeters. It just has to be 31.23 millimeters or longer of it. So it's exposed by peeling back the conductive metal sheath over here. And you make sure that's 1/4 wavelength, and then you make this section here, the rest of it, let's say 93 millimeters long. Now, what does that do? Well, it makes it not ideal, but a very good antenna, and it's still completely insulated. You very carefully stretch the insulation on this so it doesn't have an exposed wire. You cover this with a single piece of tape wrapped around it, and at this end, you chop it off and solder it back onto this board, because there's a variation of this where it has a hole you can put in one part of the solder connection, and the other part, you just spread out the coaxial and solder it around it, and now it has an antenna sticking out of it. This thing has been used, this type of design has been used for making toy drones have a Wi-Fi connection so you can send video, for instance. So yeah, we've evolved from a battery, a magnet, an LED, and some duct tape to being able to make almost the same. I mean, this is literally almost the same size. It's a little less than an inch long and a little over 1/2 inch wide circuit board. All the crap will pack onto it, especially if you desolder these connections here and clean it up a bit, and then stick this all on the back of a solar cell with maybe one battery driving the whole thing with a properly tuned inverter and a capacitor. I mean, not much more than the parts you're seeing here, just that thing there. And it's literally this, whatever you're driving, and a battery and a solar cell, and you use a battery or several, and you end up with a Wi-Fi repeater or hotspot. You could just have one side pointing up to the sky. Now we're going to do the backrooms tie-in. In the backrooms, in the meme that is the internet meme of the backrooms, there's always light sources. Now, I've already done a video on how tapping into the light boxes would be technically possible, but even simpler is just passively sticking a module made out of these parts into it. It would be invisible. You may have noticed the monsters in the back rooms don't ever break any of it, and it would act as a Wi-Fi repeater so that you could set up a ad hoc mesh network of Wi-Fi hotspots that could be used to communicate and keep an eye on the monsters. You could even add to this, because it has these abilities, the ability to put in a real simple set of motion sensors or a low bandwidth camera setup. Or go wild and put an Arduino together or something. Just saying.